All right. So welcome everyone to the Microsoft 365 Virtual Marathon. Thank you for attending and we hope you're having a great conference. I'd like to introduce our next speaker, Shahzad Masud. Shahzad will be presenting deployed to Kubernetes using Azure DevOps. This is a brand new topic for me, so I hope everyone's looking forward to this as much as I am. Go ahead, Shahzad.
Hello, everyone. Good morning. This is Shahzad Masud. I am a technology evangelist, and I'm going to present today regarding deployment using Kubernetes in an Azure DevOps environment. That's a CI/CD, continuous integration, and deployment environment. Uh, so, thank you very much for giving me the opportunity. Visual Marathon team, everyone, a slight introduction of myself. I am actually working as a principal technologist in NetSol Technologies, INC, and the company is present in California, United States, and one of my recent challenges, which I am very proud of while describing my experience, is that for the past 4 years, I am actually responsible for migration of a legacy fintech product into different offerings. And those offerings are actually simultaneously working across the board in a double A mode, I would say. That is SaaS, PaaS, and IaaS. This is software as a service, product as a service, and infrastructure as a service. I would definitely say that infrastructure as a service would be more like a platform or a template as a service scenario, which is I am doing. And right now the deployment is done across multiple organizations, and that includes very big names. Uh, I am very much focused on the security side as well, and automation and other things. I'm also a cloud and enterprise certified professional from different perspectives as well. So today we are going to talk about three distinct things. First, we are going to talk about what containers and Kubernetes are. Then we will be talking about how to create a simple registry, and how to manage a simple cluster, and how to do CI/CD over there. As this is all about orchestration and deployment, the things inside the container, and then do automated deployment in ACR. So in order to proceed further, I would like to uh, give you a little bit glimpse of what this presentation is all about, what this presentation will be expecting from you guys, that you guys are from a specific background, or what are your passions. So the first point which I consider while designing this presentation is that either you are learning containers, Dockers, or Kubernetes, or you are keen to learn, or you are starting to learn that one. Second one is either you are in a process of containerization your application, or you are planning to do that. The third one is that if you have any, if your application has any link with the microservices, or you want to move your virtual machines to Kubernetes, this presentation will actually definitely will help you move across the board. And if you're moving to cloud from a legacy application, and you want to put all your apps from one location, from a single uh, old legacy platform where all the applications are on a different machine or different ports, and they are combined through a legacy F5 or certain load balancer that are really sticky on their grounds, and it's very difficult to move. This presentation will actually help you that how you can move to cloud, and how you can actually deploy within a single control panel and a control plane where you can control everything. That's a simple cockpit where you can check and deploy each and everything with a single command. So let me tell you, that's a single command that can be hooked up from a simple pipeline as well, that can be hooked up using a CLI command line interface, and that can be hooked up from anywhere across the board. The last part, the last assumption which I actually took is if you are learning Docker and for a while you have been experimenting that one and you still think that you have not accomplished any good in that and you want to hear and you need some help on the Docker and the Kubernetes part while deploying, while working, while the DevOps part, while everything else. So this presentation will definitely help you understand all the things and all the questions. I would definitely encourage all the questions, and I would love to answer your questions and to satisfy how things are. Uh, so let's start with the first concept of what is a container, how the containers are working. So a legacy application actually have a complete virtual machine and with the underlying host, and then all binaries and apps. So that time actually is gone. Now what we do is we actually create a simple private cloud or a public cloud offering, and those private and public cloud offering actually has a hypervisor, and that hypervisor can have multiple guest OSs. Those guest OSs can be a Linux platform, that could be a Windows platform, and you can place on your binaries, your libraries over there, and the application is up and running. Uh, you can add another application over there. You can add multiple applications over there, and those applications will help you scale up or scale down. That's a real modern application architecture. In this modern application architecture, what you have to do is you have to deploy each and every application while shutting down the first one, and then deploying that, and then shutting down the second one and deploying the latest one on that one. So there is kind of a maintenance mode, there's kind of a downtime availability in this whole scenario that is not very much liked across the board. And when people actually have spent multiple sprints or multiple few hundred hours on some feature, and they want to make their feature live, they in some cases they have to put on extra hours or maybe some extra nights as well to see their feature going live. So container actually helps in most of the scenarios where container is an isolated process running on a host machine. So that means we don't need a hypervisor, we don't need an underlying guest OS, but just we need a binary and libraries available and on a container engine, and that container engine actually will help us or run all the things that are required uh, for running the application. So container is something which is like a simple image, a simple app that can run anywhere, anytime on a container engine. So this container engine helps you run and spin up the application and scale up the application in a lot more faster way as compared to the legacy OS oriented one. Why I'm saying legacy OS oriented one is that there are tons of configuration involved, there are tons of things involved while provisioning in new things. So that is one of the reason that containers are actually uh, a bit of a leader in the containerization world, and they are leader in actually deploying the application in production environment and far more liked than a legacy VM application. Uh, let's go a deep dive in the history. Containers are there long before Dockers as well, but with the name of the runtime spec and with the name of image spec, they are open source initiatives as well, already present over there, but they were not that much revolutionized uh, as they are right now with the umbrella of the blue whale, that is Dockers. So containers were a lot more shine, and over here that they are like a feather in the cap. They were a lot more recognized in this space with the Docker's platform, but they are not very much recognized with the older version. So maybe I mean, when I started learning the Dockers like 6, 8 years ago, I was also very surprised to see that there are some open source initiative already in this space, and we never look at that because of the configurational hazards, because of the complex configuration and other stuff like that. So didn't focus much on that part. So what is required over here? Container actually put in all the required information, libraries, OS libraries, OS jargons, whatever is required, and store that inside a container image. And what we need to do is we need to execute that certain process to run that particular image. That image can be stored in a public repository and can be stored in a private repository. So that repository is called, if that is a public repository, we can call it a Docker Hub. If that is a private repository, we can also add that using a Docker Hub account, and you can use that. Normally, images are contains all the libraries, dependencies, and other things. So that's why the size actually is a lot. That's why the private repositories are paid one, and the public repositories has some limits on there. But the good part is Azure also has the container registry available, and that container registry also helps us with all the things. So let me pause the introduction over here. This will give you a good brief introduction that what containers are actually and how they are working. If you want to go a little bit more deep dive in there, if you want to have more information on there, you can certainly go and check the Liz Rice, go from scratch for what container really is. That's a really good video. Here's a link for that. You can also check the Docker and Kubernetes Dockerization by Dr. Gabriel. That's also a very good book. And for people who actually likes to read the book rather than looking at the videos, this is something which is very good. And the third type of people which actually are like go on hands-on, one-on-one scenario based, and you can go for the learn Docker container on interactive based scenario. There are 20 hands-on scenarios which can actually walk you through all the process and life cycle of the Docker containers. Now let's go to understand the Kubernetes. What Kubernetes actually is an orchestration technology. Like you create multiple Docker container instances. There are like 10 instances. How to manage them, how to scale them, how to load balance them. If there any container are lost, how to check the health of the containers, how to terminate the processes, how to restart the process, how to do configuration management, how to communicate amongst different containers available, how to do all the things. That is called orchestrations. So orchestration technology is, there are many leaders in orchestration technology, but there are Docker Swarm, Docker containers, balancers. There are many other players in the market, but Kubernetes has actually gained a lot more popularity in this space just because of its clustering technology for all the container hosts. It provides a high scalability, high availability, and load balancing for most of the things. It also helps manage the life cycle as well for the containers, like dropping down, increasing span up, hot warm, hot deployment, cold deployment, health monitoring, removing the containers which are not working fine, introducing new containers, seamless working of almost all the things which are not required. And most important of all is actually uh, the aspect of uh, the networking and communication in and outside of the cluster. So important thing in all of these things are uh, scheduling, like self-healing, like service discovery, like horizontal scaling, like automated rollouts and volume management and secret configuration management. Uh, all the other orchestrators with the containers, they are lacking in a few important aspects that Kubernetes actually provide, is that other orchestrators do not provide a automated volume management and configuration management and scheduling. So compute scheduling is something which is very much in demand these days. Like you have orchestrated your container services on a machine where your compute is about to reach its limit. Kubernetes actually checks and take a good check on that one and scale up to the mark. And if that is not there, it stops the scheduling, but it remains the throttle over there. It helps you in self-healing as well. It helps you with the service discovery and load balancing. It helps you with the horizontal scalability. In previous things, whenever we need more resources, people actually go more towards like adding more RAM, adding more uh, CPUs, adding more cores into the system to actually get the things running. But in a modern world, horizontal scalability is actually something which is a lot more desired, a lot more in demand, and that is the requirement of the day. uh, Automated rollouts and rollbacks, if you want to go for any deployment, you can create an image and roll out that image across the board. That would be seamless deployment, and this deployment will be uh, with a zero downtime. And if something goes wrong, you can automatically roll back with a single command. I mean, with a single command that you can actually had to multiple schedulers as well, like Octopus, like a Jenkins, GitHub pipeline, like Git repository pipelines. You can always add that over there, like in any rollout. If you found any issue, you can always roll back. One of the important aspect of the container orchestration is there is always a high demand of debugging, common storage usage, and common configuration. So in Kubernetes, what this actually offers is it actually offers a volume management in which there are external parties also available, external volume devices and file storages available, which you can mount with your respective instances. And you can also use that particular part for all the load balanced containers, and they might be using the same site. Let's say you are uploading an image, you are uploading a file for a simple workflow, you're uploading something for and you're downloading something for that purpose. So same volume management, same volume and multiple volumes can help you do that. And the last but not the least is the secret and configuration management, like secret keys, rotation keys, auto rotation keys, and then configuration management of all your orchestration and all the containers. That is the demand of the hour, and you can use them for the best configuration possible. We have a sample YML file as well, and I'll walk you through the how the volume management, how the configuration management looks like. It's more like happening around different things. I'll walk you through that one. So let's go a bit deep dive in the architecture of Kubernetes, how that works. The Kubernetes actually has two things. One is the master, and the second one is the worker. The master is called the master or controller nodes, and the rest of the things are called worker nodes. We can also name the worker nodes as pods as well. So pods are like pods, and then in the master pod there are API services, there are schedulers, there are controllers. If you're working with a microservice architecture, then you will be using API services. If you're using a simple web-based architecture, you will be using a controller manager. If you're using this one as a scheduling service, as a scheduler worker service, you can use that as scheduler, and all the other things will be falling under the etcd. So that's the control center of all the things, where you can set up all the things, you can view, you can check every information that is running, and these are this part is actually our main worker processes, which we call pods. So containers actually get created, they get dropped. You can check different resources on them, how the container is actually working. If some container is not in a healthy mode, we can always drop that container. We can always do that. But this automatic health thing is something is that is being done by etcd and controller manager. So these controller manager and etcd actually take care of the health scenarios. If some container is not working fine, take it out, bring back the new containers, spin up the new pod, and do all the things. Uh, Kube proxy is something which actually is help you with the scalability factor as well. Whenever you have more users accessing the same system, it automatically self increase itself, self generate itself, and that helps us with the SLA of the application, and it never let you down in case of any requirement, in case of any surge in the user base, in case of any increase in the user load, or in case of any increase in the processing capability. So whenever there is a requirement, it actually spin up new container instances. It goes back to the controller manager. Controller manager actually checks all the information, check the host machine, check if we have more information over there. If the information is not there, if the compute is not there, the controller manager actually checks with another controller manager, create a link, create a queue proxy over there, and the request start falling onto this one. So this is an automated process in which we don't need to interfere in any way. So it automatically create more things. It automatically shut down to the minimum level, and all management is being done using the worker process. So we just need to understand only the four things. We just need to understand what is a basic execution unit, that is called pod. We just need to understand how to run the deployment, that is replica set with the desired state of your number of pods running, and provide ability to perform rolling updates. So we need service if we are working with the microservice environment, or if we are working with a web environment. And last but not the least, we need to check if we are accessing external services, or we are accessing external nodes. So we need to define an ingress, because if you're working in a Kubernetes environment and you don't need access to external environment, this will be a closed one because of the security reason. So no one will be able to access the pods directly. But if you want your pods to be accessed, or you want pods to access outside of the world, you need an ingress controller as well. So ingress manages all the thing that, and also also ensure the security of common things as well. So that's something which is very much desired over here. With all the knowledge base, with all your implementation, with all your consistent implementations, if you still feel that my implementation is done, but I still need to check and verify if my implementation is good or bad, and what is my rating, and can I follow some recommendations or not. So what you can do is you can go for an open source project, Kubernetes Conformis. There are many paid applications as well, but this one is free. You can simply go there, check the recommendation, do a portability check for your application, define the scenario that this is a microservice application, API based application, or a web application, or an ingress application, or an exgress application. So whatever the application is, it checks for the conformance part, and reply back with the results and rating, and you can check your results and rating. And once that is done, you can simply add this to add this badge to your application, and this is definitely a sign, and a sense of credibility for whole application where this certified actually is there. For testing purposes, you can install Docker for desktop, and when you install that, you can always enable Kubernetes over there. This is a free implementation. You can use that free implementation in a local environment. The only downside of that is you can only have a single node and a single service, but you can have multiple pods. You can test your application locally, and that is available. Docker for desktop is available for all the major operating systems, and that is also available in Windows 10, Mac environment, and Linux environment. That's available, and we can use it very effectively. That's a brief overview of Kubernetes, and if you want to go deep dive, again, I have three distinct top links for all the video lovers. You can go with James Quigley. He's the best guy, I think, in this scenario. There's a 55 minutes video that really actually covers basics to advanced level of microservice, Docker, and Kubernetes, a complete study guide. If you are a book guy, PDF guy, so you can go for the Kubernetes learning part. And if you are go for a hands-on exercise one, then Carson Anderson is the guy who can actually help you with that. The link is also available. You can note it down, and you can see it later on as well. Uh, Azure actually provide a Kubernetes service where all the things are actually there. If you are not using Azure Kubernetes services, you have to perform all the things yourself, like defining Kubernetes master, defining a plan, defining a control panel, how to scale up, how to scale down, how to certify your application. You have to do all the things yourself. But if you are using Azure Kubernetes Services, that is under a one-stop shop. All your shopping list will be done on Azure Kubernetes Services. You can easily go there, create a simple Kubernetes service, and create a Kubernetes master and pods and nodes. Add resources. That's a click and go. All the things, and you can also define the scalability. The good thing is that Azure Kubernetes Service Control Panel actually do exactly the same that I have described, like creation of the services on a command line, creation of services on all the things, certification and other stuff. So it's not like there is some implementation changes, but it is actually doing all the implementation, all the things in background on the CLI mode as well. If you are a point and click guy, then you should be using Azure Kubernetes Services. There were the detailed presentation held by the Build 2019 back in last year. You can see that if you are a command line guy, like I am a command line type of guy, and I used to write commands and see the output over there rather than point and click. So you can see a quick start on deploy Azure Kubernetes service using CLI. And if you are a hands-on guy, you can go for the really Azure Kubernetes Service hands-on workshop. There is a web control panel is also available over there that can walk you through via the Kubernetes workshop, and that workshop is a very handy one for that. If we talk about the orchestration part, if we talk about the other things, uh, and we did not talk about Helm, that's a bit of an unfortunate. Helm is a package manager that downloads and works as a proxy to all the containers. It has packages available for all the common application templates. We call those templates as charts. So if you want to deploy a microservice-based application using a Python technology, if you want to deploy a microservice-based application using C# technology, C .NET Core technology, or Node.js technology, or Java technology, you can always use a Helm chart for that purpose. There are many Helm charts available as a pre-built templating engine available, which can actually help you define your application in a lot more flexible way. It's like a template that can help you kickstart your deployment, your application infrastructure in a lot more quicker way as compared to you are actually defining all the things yourself and then doing the scalability part. Helm actually help you with all the major Kubernetes things, which means that you don't have to do a lot more work while testing the application in a local cluster environment of Kubernetes and then migrating the same one to a public cloud or a private cloud where the Kubernetes services are. So Helm actually helps you with the templating, which will be helping you across the board, and that will let you work on the templating of different packages, and those packages will walk you through. There is a complete information available on chart patterns, a video, a quick start guide, and a hands-on exercise for all the resources, and you can walk through all of them. And these are very useful patterns, which can be a very good kickstart for most of the things which are currently in the marketplace right now. Uh, this concludes the introduction part. So let me summarize this part that Kubernetes is actually a containerized workload orchestration service that can orchestrate a simple application into master and nodes, and the master actually distribute the system load to respective nodes parts, and it also manages scalability, replication, state management, volume management, containerization management, spinning up new instances, spinning down, warm up, warm down, and deployment part of all the application. So it's more like a chained reaction, or maybe the chain network where things are actually binded up inside there. Uh, let's talk about a little bit on the Azure Container Registry as well. Azure Container Registry is a private Docker registry that store Docker container images, and we can use those images to push container images uh, into the main pipeline. Whenever we are deploying an application, whenever we are working in an application, and we need to deploy our changes, what we have to do is we can build that application and create the image and push that image to a registry. Azure Container Registry actually is that part where we can use this one uh, to store those images, and in order to store those images, you can always use that one. Uh, in order to use that registry, it is recommended to use command line. You can also use the point and click interface of Azure control plane, but I would definitely recommend you to use the command line. You can install the command line interface. CLI version, it's a very much similar to the partial version, and you can issue a command of az space -1 version to actually get the latest version that is currently available. So as soon as you are done with that, with the AC WW with the version part, we can always check where we are. Now, the first thing first, you have to set up your subscription or your subscription ID over there. Then you can create a simple resource group with the location. The resource group is actually for which location you want to use. Let's say you are in US, west side of US, east side of US. You want to use that particular region for that purpose. So you can create a resource group over there. Uh, Again, as I recommend using command line, but it's not compulsory to actually use command line. You can always use these things over there inside your point and click as well. Container registry. You can also create a container registry by the name of a container registry name. Over here, I actually named that to my container registry 007, and with a SKU as a very basic. So you can see that you can also create this container registry using the point and click in the control plane of Azure as well. But if you do not, this will not impact that much. Uh, this container registry and this all the things, you can take note of them, and you can add them anywhere whenever you want to use the container registry again. But if you don't remember that, always go to the Azure control plane and go there and check from there. Once you are done with that, just log in on Azure control registry using the command line azacr login minus name. That's my container registry 007. You can always go there and log in over there. So this is something which is required part. This cannot be done. The last part, this cannot be done without using the command line interface, because this requires you to actually log in on application, and then when you are pushing your images, which I described in step 1, you have to log in first and then push your images. Otherwise, this link is not established. As this is a secure link and this is required very much, so that's why this login information will be sent along with the every version of that image. There are multiple ways to actually build your pipeline, but the best way to build the pipeline is go to your dev.azure, create a new organization and a new project. Uh, Pipeline is a continuous integration and environment which is required step for uh, how to automatically deploy your application over there. So once you push your image onto your ACR, Azure Container Repository, this pipeline will automatically deploy from there by using a hook from that particular one. So that hook which is required to deploy over there, is that hook is called the pipeline. So pipeline actually says how to create that. You go to dev.azure.com using DevOps, and you can go to organization and a new project, name the project as sane. You can create a simple pipeline using the repos over there, select the repository name for the respective job, and you can use a starter pipeline or YML file. I actually recommend a YML file. uh, there are few reasons for that. Starter pipeline also create a YML file, but in our scenario, what we do is we actually modify that YML file any time in our repository, and that will be changed. But if we use the starter pipeline, the starter pipeline will remain same across the life cycle of the application. Let's say you can only change few things in the pipeline, but if you're using a YAML file, you can change all the entire structure of the application. So YAML file is like coding your infrastructure in such a way that you have complete control over almost all the things. So there are 7 steps involved in this whole scenario. The first step involved is uh, you just have to create simple Microsoft agents. Most of the modern applications which are actually being developed in .NET are .NET Core, and .NET now can run on non-Microsoft or non-Windows platform as well. Like over here, I'm actually using Microsoft host agent for Ubuntu, and I'm creating a pool for that. I am building, I'm pushing a Docker container application over there, and I'm creating a simple ACR, a Docker compose file. This Docker compose file is there to build the services. This services will push the Docker image to my ACR with the subscription, a different ID. I actually add XXX on the Azure subscription part. You can replace that one. This is a push service JSON file, which we can use in the same way, like the Azure subscription ID with the push service. You can push the same container image over there, build the container image using this YML file, and push the service using this YML file. And once that image is pushed, you can actually check and publish the artifacts as well. Pushing to the Azure Container Repository is not enough step actually to check the information, because publishing and depublishing are the two artifacts which are required to promote your image into production. If you run this build pipeline to publish the build artifact, then that will be deployed across the AKS Azure Kubernetes Services. But if you don't go for that, so it will only store over there and it will not trigger the whole job for the build scenario. You can also use Azure Functions as well. You can also use Azure Virtual Functions as well to do this job. There are multiple ways to do that, but that is like, doing the job in an ad hoc and alternate way. This is Azure DevOps is the right way to actually publish the artifacts in the whole scenario thing. So once you are done with that, now let's go to defining the cluster step. The cluster step is there, cluster step that actually works very well, and that is there. You can use the command line interface as well, and over here you can also use uh, the control panel interface of AKS. You can use that. As I mentioned, that I really like the command line interface. That's why I pasted my favorite one, like AKS create resource group with the name of my cluster, how many nodes or pods I am interested in, and do I need to monitor this cluster, and then do I need to generate SSH keys or not. So using these simple commands, I can simply create a cluster. Once the cluster is created, I would need to get the credential of that cluster. So in order to do that, I issued a command of get credential cluster for my resource group and my cluster name. It download the cluster and configure that one within my local one. So I need Docker or desktop application in order to run and in order to access the kube control from my local machine. And once I do that, using the Azure command line interface, it actually do a handshake of all the credential stuff. And this is actually my current node and my current cluster that is up and running and ready for the service. Once this whole step is done, you can simply verify this step by actually calling kube control get nodes, and this get node command will let you know that you are up and running, and you can simply check the whole environment that it is up and running. If the nodes are not returning, that means either you're not connected to internet, or your credentials are not correct, or there is some other problems with it. So uh, these are important stuff. Once you are done with that, you can describe a desired state of the cluster. For that desired state of a cluster, you can always create a simple namespace that we can create a deployment, we can create uh, a service, we can create an ingress, we can create a config map. So namespace is an important part. So in order to create that, you can always issue a command of kube control ns namespace, and that namespace will create a respective namespace. Once that is done, now the whole point actually moves on to your YAML file and load balancing file, how you define the YAML and load balancing stuff. And that is now it's time to expose to your external world. So external world exposure is Azure service.yaml file, and the load balancer. Let me show you a sample YAML file and pipeline file. This is a sample YAML file that contains the API version, its kind as deployment. The metadata is a simple voting application. That voting application has a specification of a one replica, not much replica. Its template is already there with us. The vote banking application. We have Redis available in the container. We have a CPU at 100 M with a memory of 100 megabytes with a CPU limit of 250 megahertz and a memory limit of 256 megabytes. We have certain ports available that are required to use. And then we use another tag in there for the service. That's a vote back services that will access this service using 6379 port. And then we have another deployment of the front end services, which will check the front end service. That front end service is working over there. Again, there are replicas available, and the front end and the back end services. And then we have a simple load balancer. If we select more than one replicas over here, then this load balancer will be actually working as a single service with multiple ones. Here is the repository information, Microsoft Vote application with a front end version, and we can use this one for our for deployment. You can use your own one, but that's something which is a lot more better over here. Node selector is beta.kubernetes.io Linux, and we are using a Linux flavor. And for deployment, we also created a simple pipeline. All the steps which I've mentioned over there, you can always use this Azure pipeline inside your repository, and this will install, and this will do all the build, push, and publish artifact services over there. So these two files, if you actually place these two files inside your repository, you don't need to do anything. So Azure service.yml file, Azure pipeline.yml file, these are enough to actually roll all the things. So this is the final step. And when you're done with that, you just simply create a JSON file with this name, and you can deploy using kubectl deploy using this JSON file. This JSON file contain all the properties and all the steps, how to do all the things, and what are the inputs from where the cluster is actually taking part. What is the cluster resource group, and where is the configuration file, where is the authentication key, what is the secret type, what is the version specs. So all the things are actually here, and you can deploy it using that one. uh, if everything goes smooth, you will see things in your Azure pipeline in the logs that everything is there and all the pods have successfully deployed everything. Um, you will always see a warning on kube control apply, because this warning is always there because of the fact that if you are deploying from a CLI version, you always get this warning. If you are deploying from a web version, you are doing an automated deployment, then this warning will not be there. So so this warning will remain there for the CLI part. So that's it. Whenever you actually issue a build command, whenever you issue a build stuff, it will automatically trigger the DevOps using itself and do all the steps, and the whole deployment and whole upgrade part will be done in no less than 4 minutes or something with a zero downtime. Its deployment part is like in such a smooth and seamless way that the application is not down, they're progressing, they're servicing, and as soon as there is a new release comes up, it actually put the load on the upgraded version, and take all the older version non-servicing. So it's like a blue-green deployment kind of a strategy that automatically deploy all the things. So the heart of the whole scenario is these two files, and these two files are generated using Helm, and you can always get these files and get these applications running yourself, and you can do experiment over there as well. So that's it from my side over here. I'm happy to take any questions from you. any questions if you have on this one?
Thank you, Shahzad. We don't have any questions in the Q&A, but if anyone has any questions, do you have contact information where someone can reach out to you?
Yeah, sure. I have put up my contact information over here, and if anyone actually has any information or any question to share with me or ask any questions from me, he can reach out to me on my Gmail account, on my Microsoft account, on the Twitter account, Twitter, Facebook, Instagram, all the accounts, and I can be reached, and I'll try to respond as soon as possible on those places uh, as I can. Uh,
Great, we appreciate it.
I would definitely encourage, appreciate all our generous sponsors. Without them, that is not possible. And also, I would like to thank all our champions. They're fighting with the COVID situation right now, and I definitely encourage every one of you to actually consider donating to the following charity relief funds as well. And these medical corps are actually really helping the humanity in a lot more better way, and we actually need all of them. Um, there is a raffle also available. So uh, if you are up for a challenge for the raffles, there are three Oculus Quest are all available with the 5 correct answers. You can always do that, and mark your calendars for the next event. Hope to see you guys over there, and still I'll be happy to answer any questions now or maybe later. Feel free to send a note to me. I'll be happy to answer that.
All right, thank you.
Thank you very much.